we're going to work with the element bromine and the element silver. As you can see, bromine is right there, okay, number 35 in this side of the periodic table. So what do we have to do in the first place? As I told you the other day, we need to focus on what we can find in that periodic table. So bromine is the symbol matters. Okay? The symbol that is Br and the atomic number that is 35. Okay, so just remember what every letter means. Example S can hold up to 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold up to 14 electrons. Okay, just remember these letters and its significance. So, what do we do? As I told you the other day, we always start from this position right here. Okay, and what we do actually is we follow the direction of the arrow. So remember, S represents 2 electrons, P represents 6 electrons, D 10 electrons, and 14, F 14 electrons. So we're going to be filling the 35 electrons by following all these paths, okay? Just remember the Christmas tree arrangement. So we say for bromine, the electron configuration will be 1s2, 33 electrons to go, okay? 2s2, 2p6, okay? We were here, then here. Now we're moving into 3s. 3s, s can hold 2 electrons, okay? Then we follow the arrow until we get to P, 3P. Remember that P can hold up to 6, okay? And we are counting all the electrons in our mind. So what I do is I know that here I have 10 electrons, okay? And I need 35, so I'm good. I need to continue. After 3P, I continue to 4s2. Now I reach 10 more electrons, which means I need to continue. I need 15 more electrons, okay? So I continue, I follow the arrow, and take a look. Now I move to 3D, 10, okay? Here I have 10 more electrons, which means that I need 5 more electrons, okay? So I go to the next one, which is 4P, but instead of using 6, which is the most that I can use, I'm gonna be using just 5. The 5 I need. So this is going to be 4P. Remember, instead of 6 that I can hold up, I need just 5. So I'm just going to use 5. So when I add all the electrons, 2 plus 2 plus 6 and 5, I will realize that I have the 35 electrons needed. So, so far, that's all the electron configuration. All this is the electron configuration. Now, if I ask you number of electrons in the outermost level, say what I have to look at is at, at the greatest coefficient. Okay? Remember that the coefficient is this one right here. 1, 2, 3, 4, 5, 6, 7. So I have to look at the greatest coefficient, which is 4s2 and 4p5. So in the outermost level, I have 4s2 and 4p5. Now I'm going to focus on adding all the electrons, okay? Only the electrons. The electrons are like the exponent. So how many electrons I have in the outermost level? 2 plus 5.
7.
7.
Yes. So number of electrons in the outermost level is going to be 7. And then this part I didn't teach you the other day, but it is the part where we need to show the structure of bromine atom. So to draw the structure, this part you're going to be needing probably so what we do is we're going to focus here. You are going to write the element symbol, okay? Like I did here. And I will draw some rings. You need to be perfect. But, slightly better. Now, what am I going to show here? Now, take a look. This ring, that is the first one. This ring right here is the first one. This is the it represents the quantum number 1, the quantum number 2, quantum number 3, and as you can see, how many quantum no, how many quantum numbers we did here? We got 1, 2, 3, and 4. So that means that we need 4 rings. I need one more ring to do. So this represents the quantum number 4. And what I'm gonna do now is I'm going to include all the electrons that I have in each level. For example, in the first ring, I just have 2 electrons. So I can put them here. 2 electrons. In the second ring, okay, in the second ring, I have 2 plus 6, okay?
Eight.
We just add the electrons. We have 8, okay? So we're going to draw 8 electrons here. So what I do to make it beautiful, I put one in the top, one below, east, west, and then one, two, three, 8 electrons. I continue and I move to the sublevel, to the quantum number 3, that I have 2 plus 6, which is 8, and then I have 3d10, which is 18. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, and then I put the other 6, 4, 5, and then as you can count, the 18. 1, 2, 3, 4, 6, 7, 8, 9, 10. 1, 2,
Why
3.
did you put 18?
Huh? What did
Why
I
they
put?
are 18?
Because I have in the third ring. Remember that the ring is the coefficient. Okay. So for the coefficient 3, I have 3 as 2, 3 plus 6, but I also have 3d10. So I add 2 plus 6 plus 10, which makes 18.
Okay. And I didn't understand where did you get the outermost lever, the 4s2, and because I don't know why that numbers did you choose?
Because I take the number with the I take the number
With
that
the greater coefficient.
the greater coefficient, okay? The greater coefficient in all this is the 4, okay? The 4 here and also the other 4. So what I do is I'm just going to add the electron 2 plus 5,
Okay.
which makes the 7. And those are the electrons that you are going to show in the outer level, which is right here. And I'm going to put them in different color, mm, just because I want.
And my last question, I want to know, you tell that that part has a name, the quadrant, no, the, I don't know what's the name of all the ones that you put in green.
Quantum number. That one?
Yes, about all the line that was in green has a name, you said.
The coefficients, the greater numbers are known as quantum numbers. And then in the outermost level, as you know, we have 7 electrons. So I'm going to put them in the outermost level. 1, 2, 3, 4, 5, 6, 7. Mm, With this right there, what you did is the structure of the element bromine. So remember when we did the foldable about the atom structure, and some of you printed the the atom of every element. So what you saw over there is exactly what we just did. The arrangement of the electrons. What you see over there in the structure is the arrangement of the electrons. That's the arrangement that matters. And most importantly, what matters the most is the outer ring. I'm gonna put it in a different color because of that. So what matters? Okay, first of all the configuration matters, okay, but we're always going to focus only in the outermost level because from here comes the next topic, okay? But you need to know how to get to that part. Now, just remember all these dots are like, and here you can visualize the atomic theory, okay? In the center, what you have is the nucleus of the atom, and surrounding the nucleus, you have the electron cloud there is all that bunch of electrons spinning around the nucleus. This is what happens. Okay. Now this is just a drawing, a sketch. In reality, is what I like show you in the presentation. Okay, the gift image of the electrons spinning around the nucleus. Now, those electrons are represented here by these little dots. And this is basically what you have to do. So I'm going to develop one more example for you to work in this homework, okay? And that you'll be ready for this week's quiz. Now, what's coming in the quiz? It's coming all the Avogadro's conversion, all these conversions, plus the electron configuration, okay? Now, in the quiz, I am not going to ask you to do this, but you're gonna do it in the homework. Now, why not in that quiz? Because of the time. Because this takes quite some time. Okay, so you're not going to do this in the quiz, but you will do it in the homework. So yes, you need to be like paying attention because of that. And what else? So what you're gonna do is just this configuration that you see right here and the Avogadro's conversions that we did the weeks before. Tell me, Christy.
We won't have theoretical in the quiz, right, Miss?
No, just practice.
Thank you.
Okay. Let's focus on the next one. So, in what position is silver in the periodic table?
47.
Okay, and the symbol is Ag. Okay, so that's the first step that you have to do. Focus on finding the element. That's why it's good that you kind of know where to find the element. Now, what we need to do next is what is it? Just remember S is 2, P is 6, D is 10, and F is 14. I always put them just in case I need to remember those. Remember, this is a quantum number, and okay, so as we said, we need to start from the beginning, right? So the electron configuration, I simplify it as ECN, okay? So the electron configuration notation is going to be, we begin here, and we say, okay, 1 is 2, continue, 2 is 2, I follow the dot line, and I continue with 2. Remember that P is 6. Right now, I know that I have 10 electrons. So I continue. I continue to 3s, 2. And I follow the dash line, and then I go to 3p. P can hold 6 electrons. And I continue where it says 4. 4 can hold, 4s can hold 2 electrons. In here, I have 10 more electrons. So I need to go on. Sorry. So I continue. I follow the dash line, and it goes 3D 10. As you can see, I like separate the electrons in groups of 10 because for me it's easier like that. But you can do it in the way you want. Just don't lose count. So after I have 30 electrons, which means that I need 17 more. So I continue. For P, 6, and I continue. 5s, 2. Okay. So I follow the dash line, and I have 4D10. Remember, we were needing 17 electrons. Okay. Here you need to have 17, but if you add them, you just have 18, which means that instead of using the 10 right here, you will just need to use 9. Now you have the 17 requested. So in this part, instead of using the 10 possible, you're just going to be using 9 out of 10. Okay? And with this, you can say that you have the electron configuration for silver. If you want to make sure, you can still do it. You can count again and make sure that you have it completed. Now, what comes next? We need to get the number of electrons in the outermost level. What is the outermost level in this configuration? What is the greatest quantum number?
5. 5s squared.
Mhm. So the greatest n is the 5. Okay, and that's the only 5 that we have, so we're going to write it. The outermost level is in the quantum level 5, can hold 2 electrons. So in total, I have just 2 electrons in the outermost level. And what comes next? How many rings are we going to draw?
5.
5 rings, okay? So we're going to be drawing 5 rings. And the next step is just to put the number of electrons in every single ring. So in the first ring, how many electrons do you need to put?
2.
Okay, in the first one, 2 electrons. In the second one,
Eight. Eight.
8, 2, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. And in the third one, how many electrons?
18.
18. That one is time. Okay. Right. Yes. Now it's working. Um, okay, in the third ring, uh, yes, 18 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many in the other ring? In the ring number 4, how many electrons?
17.
17. Another one. Six, 15. Y luego in the last one, in the ring 5,
2. Two.
just 2. So here you can actually visualize how many electrons you have in the outermost level, and above you have like the calculation. So as you can see, like the topic actually is very, very simple, but this sketch of each electron, is, I mean, of each element, is gonna have a lot of work to do. Okay, so guys, this is it for the. This is the electron configuration notation full. Okay, the full structure. There are other methods that I will teach you later. Okay, but not today because of the time. So what's coming in the quiz? This topic, okay? Plus the conversions for Avogadros and mass, okay? Grams to atoms. This is like the most complex topic. So remember to to practice, watch the videos again. In my YouTube channel, I have some explanations that I did other years. You can use it. This is study for Thursday, and physics quiz is going to be on Monday, so I can give you a review tomorrow, and you can do the quiz on Monday. Okay? And remember that for
You
next week,
tell us that the topic that we see today, but we only are gonna do the electron configuration. We are not gonna do the rings.
yeah, not the rings, because it takes a lot of time. But you're gonna do rings for the homework. Okay? Just so for next week, remember that I told you that you're gonna do like a project, which is an exposition, and not it's not going to be like in class exposition. You're going to record a video solving two exercises that I will give you. Okay? And that's going to be the homework is going to be individual. And how are you going to do it? You're going to record yourself doing the two exercises, explaining me how you did it, and you will upload it to YouTube, and you will send me the link so I can watch it. Okay? So that's that the project is for both classes. So I'm going to send you two exercises. It's going to be random. Okay? So this is it. Bye, guys.